From now on, let me introduce how to use Stowage Optimization Program, RedStow. RedStow program has two major functions, optimizing and editing. Optimizing is the function to automatically create a stowage plan, while editing is the function to modify or adjust the stowage plan created by the RedStow. This session, I'll demonstrate the whole process from starting the optimization engine to creating the actual stowage plan. The entire process of running the optimization engine, creating a stowage plan and checking the results, takes place on the Config tab, the Optimize tab, and the Summary tab on the program. On the Config tab, Planner can view inputs such as bookings and ship schedules, set user options and optimization conditions. On the Optimize tab, Planner run the optimization engine. Also, the Config tab has the visualization system to show the overall optimization processes creating a stowage plan. The Summary tab shows the result after optimization, such as cargo loading quantity and weight by hatch and tier, workload by gang and gang split plan. Now, let's select the vessel import we want to build the stowage plan on and actually run the optimization engine. Selecting the vessel import for planning is done in the Select Vessel Import combo box located at the top center of the Config tab. First, click this combo box, and the list with vessel import name appear. Then choose the vessel import you want to make stowage plan from the list. This time, choose the MV01 Kaohsiung. When you choose the vessel import from the list, various information about the selected vessel import appears on the screen. The ship schedule import information are displayed at the upper part of the center, and the booking information by OD and cargo type are displayed at the lower part of the screen. First, look at the ship schedule for the selected route. It shows this vessel operate on the route where cargoes loads from Kaohsiung, Shanghai, Ningbo, Hongkong, Port Kelang, and discharges cargoes at Greece, Notre Dame, Felixstowe, and Hamburg in Europe, and shows the number of working gangs, GC spec, such as GC height and reach, berthing direction and the required departure condition at each port. And right below, the number of bookings information by OD and container size are displayed. The row that POL has IPORD shows the onboard quantity about the through cargo's transport from Europe to Asia. The rest of the row lists the cargo quantity to load at Kaohsiung, Shanghai, Ningbo, Hong Kong, and Port Kelang each, according to the booking summary of the Asian region. The first port Kaohsiung has 1,423 TEU, Shanghai 3,714 TEU, Ningbo 4,699 TEU, Hong Kong 2,813 TEU, and Port Kelang has 1,559 TEU. Shanghai and Ningbo have the largest cargoes of booking, and Kaohsiung and Port Kelang have relatively smaller. In Europe, Rotterdam has the biggest discharging quantity of 4,844 TEU, and the final port, Hamburg, has the smallest of 20 to 89 TEU. In the case of special cargo, at the first port Kaohsiung, 25 boxes of DG, 7 boxes of reefer, 9 boxes of OG are loaded, and the final port, Port Kelang, has the biggest reefer load of 57 boxes. And at the bottom of the table, the total cargo quantity at the final port, Port Kelang, is 13,114 TEU, which is approximately 95% of the ship's capacity of 13,808 TEU. Next, let's take a brief look at the vessel's arrival conditions at Kaohsiung. Arrival conditions can be found on the Optimize tab. Currently, the main stowage screen at the top is empty since the optimization has not started, and the secondary screen at the bottom shows the arrival bay plan at Kaohsiung. In the plan, the gray cargo inload at current port, Kaohsiung, and the rest is the through cargoes going to the next port in Asian region. On the right, you can see the status box. At the bottom of the current status box, GM, trim, heeling, ballast, and total displacement are displayed. These are the figures that show the vessel condition before the start of loading cargo, after unloading of cargo at Kaohsiung. According to the vessel condition before loading, GM and trim are not in bad condition, and it seems that there will be no difficulty in securing the departing condition of the port. However, it is necessary to set attention on GM while stowage planning on this voyage, because at Port Kelang, the final port of this voyage, full booking of cargo is expected. Go back to the options setting part of the Config tab and set the optimization mode 3, which is the mode focus on ship stability, and click the Apply Settings button to save the modifications. After changing the options or optimization conditions and saving the changes, Go back to the Optimize tab again and click the Start button to run the optimization. The first step of optimization process is to determine the appropriate stacking height at each port. By analyzing the initial cargo loading status and the loading and unloading schedule for each port. If the user enters the stacking height, the engine does not perform the process or estimating the stacking height. However, if the user does not enter the stacking height, the engine will first determine the appropriate stacking height in the height estimation module. And then based on this stacking height, optimizes the block stowage pattern at the target and final port. Finally, the engine optimizes the stowage plan through a slot allocation process that assigns each container 2 slots. When the stacking height is determined, the gray and green lines are displayed on the stowage display screen. The gray line indicates the planning reference stacking height of the target port, Kaohsiung, and the green line indicates the reference stacking height of Port Kelang, the last port of this voyage. It also shows the number of the reference stacking height between the main and secondary stowage display screens. Planner can see that the engine has determined the reference stacking height for the target port as 7 and for the final port as 9. Once the stacking height for each port is determined, the engine processes and transforms various input data, such as cargo booking, ship schedule, last bay plan, optimization condition, and options, into the internal formatted data compatible for optimization math model. Currently, the engine is creating an optimization model for the block stowage pattern, which is a set of stowage conditions and constraints. The block pattern model allocate the cargoes that is aggregated in POL, POD, cargo type, container size 2 blocks. During the block pattern optimization, engines start to find blocks for special cargoes, such as DG, Rafford, OOG, 45 feet container. Finishing the assigning special cargoes, and assign the 20 and 40 feet dry container 2 blocks. The engine evaluates whether the current block pattern is optimal for several factors, and repeat these process finding the optimal block pattern by adding these factor one by one. This process is repeated for all ports from Kaohsiung, the first port on the route, to Port Kelang, the last port. Once the evaluation process about the block pattern of Kaohsiung, the target port, has been completed. Next step, the engine will repeat the similar evaluation process for Shanghai, Ningbo, Hong Kong, and Port Kelang. Through these evaluation and feedback loop, the optimization engine repeat the task of finding the optimal stowage pattern for the entire port of call. Not only for Kaohsiung. Currently, the booking cargoes of the next port are allocated to the block, assigning the cargoes of Shanghai, Ningbo, Hong Kong, and Port Kelang. The engine is calculating the combination of optimal block pattern by evaluating repeatedly stowage factors of each ports. For instance, whether the rehandling operation has been minimized, whether the cargo is well distributed along the longitudinal, horizontal, and vertical direction, and whether the ship's stability indicators such as GM, heeling, trims, shear force, and bending moment are acceptable. Once the optimization of the block stowage pattern for Kaohsiung and the rest of the port on the voyage is complete, the main screen shows the block stowage of Kaohsiung, the target port. The secondary screen below shows the expected block stowage pattern at Port Kelang, the final port on this voyage. There is a log box at the bottom of the screen showing the optimization processes. This log box provides hints about the optimization process. It tells the engine is optimizing the Kaohsiung block pattern by evaluating the several evaluation factors sequentially. Whether being minimize the rehandling operations, minimize unnecessary hatch cover operation, will assign the light cargo to proper block, well-distributed cargoes along the longitudinal, horizontal, and vertical direction, and well secure the ship's stability indexes such as GM, heeling, trims, shear force, and bending moment. Below the log box at the bottom of the screen, the number of optimization processors processed so far, the elapsed time, and the rate of progress are displayed. It shows that about 27% of the total optimization progress is processed currently. Now the optimization engine translates the stowage conditions and evaluation indicators from the block unit to the slot unit, and creates optimization conditions for the slot allocation of individual containers. These modeling is expected to take about 1 or 2 minutes. Now OOG model, DG model, 45 feet model, and general cargo model have been created for slot allocation process. The current process is to verify that the individual cargo models have been properly made without errors. And this process creates possible combinations of container and slot pair, namely candidate loading instruction for all booking containers and slots. From the target port of Kaohsiung to the final port of Port Kelang, the number of these possible combinations increases exponentially with the size of the ship and the number of ports of call. For this reason, this process requires the most computation times of the entire optimization process. When making the loading instruction, the container stowage rules such as the limit of stacking weight and height, and IMDG rules are reflected. In addition to these general stowage rules, if there are special loading schemes of individual companies or routes. For example, DG, Rafford, OOG loading restrictions, or 20 feet stacking schemes. These special loading rules are also reflected when creating the loading instruction. From now, the slot allocation for each containers is the process of evaluating the candidate loading instruction created at this stage, and is the process of finding the combination of loading instructions that can obtain the best stowage evaluation values from the target to the final port of call. Currently, the main screen shows the slot allocation process for the Kaohsiung cargoes, and on the lower secondary screen, the general projection for Port Kelang are displayed. The general projection shows the slot allocation process for special cargoes that will be loaded from all ports of this voyage. Like the previous block stowage optimization stage, the engine optimizes the slot allocation by evaluating the several evaluation factors sequentially, scoring about the evaluation factors, evaluating and adjusting the loading combinations. This optimization process is repeated for all ports from Kaohsiung, the first port on the route, to Port Kelang, the last port. In addition to the evaluation factors considered in optimizing the block stowage pattern, several factors are considered in the slot allocation processes. Minimizing void space due to the high cubic or OOG container, and locating the container position considering weight distribution within the block. Currently, the secondary screen shows the weight distribution of the Kaohsiung stowage. During optimization, users can choose the output of the secondary screen by selecting the list in the left side combo box. It displays the current status about the selected item. When slot allocation is completed, a bay plan must be created. In this step, the detailed cargo information such as the container number are mapped to the slot allocation result. If a restow operation occurs, the mapping task for those containers are carried out at the same time. After mappings for all containers, the final bay plan is completed. Now, ballast optimization is carried out and determine the amount of ballast for each tank and the ship's safety indicators, such as GM, shear force, bending moment, and so on. With the ballast optimization, all optimization processes are complete. According to the Kaohsiung stowage optimization results, all cargoes were assigned to a slot location without rehandling, and found that the ship's departure GM, trim, and various stability indicators were also satisfied, within an appropriate range. The stowage plan currently displayed on the top main screen will be the final Kaohsiung bay plan. On the lower secondary screen, the general projection diagram for the Port Kelang block stowage is displayed. And selecting SP cargo in the combo box, the stowage diagram for special cargoes to be shipped from all ports of the voyage is displayed. If users want to modify the bay plan created by the engine, user can easily and conveniently modify the plan by referring to the general projection or SP cargo diagram provided on the secondary screen. Finally, the detailed cargo loading statistics can be found on the Summary tab. The Summary screen shows the cargo loading weight and quantity by hatch and by tier. Also, it shows the gang workload and the gang split diagram. On the left of the table, there are G1 inch and G2 inches characters, each of which stands for a stevedore or gang. The number next to G1, G2 characters indicates the amount of discharging and loading work each gang is processing. And the number on the right side of the row indicate the loading and discharging quantity at each hatch by the gang. Here, we will finish the demonstration about the Kaohsiung stowage optimization. In the next session, we will continue to make the stowage plan from Shanghai using the stowage plan of the previous port created by engine as the input of inbound bay plan for the optimization run. We will repeat these optimizations until the final port, Port Kelang, and will make sure whether cargoes are loaded and ship stability are satisfied. Thank you.